Everyone, I'm Alexander Ramirez, and today I want to help you out with modular arithmetic. It's really not that bad, or at least in the examples that I've been shown. So hopefully I get to help you out if you just happen to not understand something. So usually with like these low-level modular arithmetic type questions, you'll be asked to find the remainder of a number or an even larger number. So let's say you're asked to find the remainder of 2153 when divided by, and you might have a whole list of numbers, 2, 4, 6. It's really all the same. So let's just focus on 2 here. So find the remainder of 2153 when divided by 2. So an interesting thing to note is that this is essentially the same thing as this. I should make this a 2, not a 7. So 2153 is congruent to modulus 2. I apologize for my cat in the background. He does not leave me alone ever. So if you recognize this form, you might just know off the bat what we sort of have to do to find the remainder. If not though, that's why I'm here. So we have n is congruent to qm plus r, which is sort of the fully realized version of this with some more information here. So if we can fill this out, we can solve for our remainder. So what is our n? Our n is pretty simple. N is just our number. Okay, and so what's our q? We don't know what q is. And what's our r? We don't know what r is. That's what we're solving for anyways. But we do know what m is. M is our, as you can see here, m is our mod. And if we didn't write it like that, you know m is from our question that was asking us to find the remainder of 2153 when dividing by this number. So if you're ever in a situation where you're asked to find a remainder of a number when dividing by a certain number, that's more than likely your modulus. So let's write down what we know for certain. Alright, cool. So we have this. We have our q, or I'm sorry, our n, and we have our m. We're trying to find our r. So how do we get a q? Well, to get a q is even more straightforward. We just divide this number by our n by our m. So 2153 divided by 2 gives us 1076.5. We can omit this 0.5. We just want the whole number, and this goes for pretty much everything when dealing with modular arithmetic. So let's rewrite what we have. So that number is congruent to 1076 times our modulus plus r. Here it's pretty straightforward. We take our 1000 times it by 2, we get 2152 is congruent to 2153. And to find our r, we can just subtract both sides by this number, and you get 1. So fairly straightforward. Let's do 4, just so we can get some more practice with this. And I will try to be silent, so if you are doing this next to me, you can recall information and whatnot. I'll probably still talk, so I don't know. So we got 2153. Well, we know we need to divide it by 4, so 2153 divided by 4 is 538 times 4. Okay, so what's 538 times 4? 2152. And I just know simple is just 1. So 1 is also our remainder here. So hopefully that helps a bit with the more simpler numbers. I know it's a large number, but it's relatively simple, but you'll know what I mean when we talk about large numbers. Especially when we are dealing with exponents, which are usually very large numbers. So what happens if we're tasked with finding the remainder of this? Find the remainder of 5 to the 2,456 when dividing by, let's just say, 3. This is a super big number. If you're to plug into your calculator to try and like just do the n equals, qm plus r, it's way too big of a number. It might give you in the scientific form or whatever, I don't know. So really that takes too long. Professors like to teach a way to sort of simplify your exponent down, and then to further simplify it down, and to further simplify it down. I think that's too much work. Frankly, you can't really escape the workhorse that this question requires, but you can make it simpler, and that's to turn it into binary, which I know sounds scary, especially if you are not a computer scientist, or you might think it takes too long, but it's actually not a grueling process at all. I think it's pretty easy, and if I'm saying it's easy, then it genuinely is easy. So how do you turn this number into binary? Well, if you have a calculator that lets you to do it, just plug it into your calculator. If you are like my university and they don't allow calculators that do that, then you'll just have to do it manually by hand. So how do you do it manually? Well, just do it. Plug in your exponent number divided by 2. So we got 2456 divided by 2 is 1228 with a remainder of 0 because we have no decimals. It's just a clean 1228. So 1228 divided by 2 is 614, remainder of 0. And you just keep going down and down and down until you get to a point where you're dividing 0 over 2. At that point you can stop. So I'm going to cut, and like I said, if you end up getting a number, I don't know what 614 by 2 is, but let's say you get like, I don't know, 152.6, omit the 0.6, put a remainder of 1, and then 152 divided by 2. Alright, so I'll meet you when I'm done with writing this all out. Alright, so this is what you should get. I do want to make clarification. I did say something about stop when you get to like 0 divided by 2. That makes no sense. You need to stop whenever your result gets to 0. Right? You do not continue any further. It actually does make sense because you're just going to keep getting the same answer, but I just wanted to clarify and make sure that you aren't writing down the wrong thing. But yeah, essentially, if you didn't really get it, just divide by 2. Is there a 0.6 or 0.2 or whatever? Put a remainder of 1. If not, put a remainder of 0. And just keep dividing it by 2 until you get to 0 being your sort of result there. So how do we put this in a form that'll help us? Well, we have to write it in a form that we can read it. So when writing it, and I want to stress this, you want to write it left to right, as in 1, 0, 0, 1, starting from the bottom of your list. So this is what we just recently wrote. This is our last result. So we're going to start with 1, 0, 0, 1, as I've written up here. 1, 0, 0, 1, 1, 0, 0, 0. Right? So you want to, the most recent thing you've written down, you want to write down first on the left-hand side. And then just go down to the right as you progress through your list from bottom to top. I hope I didn't make that too confusing. I just wanted to stress that because I have seen people make mistakes where they try to go from the top of the list, as in 0, 0, 1, 1, and that makes no sense. So now that you have that done, don't worry, if you're not a computer scientist, you don't really have to know anything about the positions and the number that corresponds with the position. You just need to know this number. So in fact, we can just erase all of this because we have all we need at the top. So we have 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0. Rewrite this somewhere that that you can make a table out of, because we're going to need to organize the data that we're going to get to find the remainder. I apologize for the messiness. I'm not used to using like a drawing tablet for writing. Alright, so how can we actually begin this problem? Again, if you have a calculator, you would have gotten this number binary. But how do we approach this? So we can take our base and put it into this first slot here, 5. And so now that we have this 5 here, we can take the next step into our table. And our goal is to reach it all the way to the end. And our number at the very end will be the remainder when dividing it by 3. So how do we start this? And it's important to note, do not skip this portion of the video, because there are different ways to calculate a 0 and to calculate a 1. And I'll show you this. So how do we start? 0 is actually our like base, so it's good to start with 0 here for in terms of like the steps that we need to take. So when we're jumping to 0, what we need to do is take this number here, and for convenience, for simplicity, I'm just going to call it our remainder. So 5 is our remainder. Square your remainder, modulus of whatever you're dividing by, just like how we did in the first question. And just like the first question, we can sort of rewrite this as this, where our goal is to find the remainder, right? So this is pretty straightforward because we've done this a couple times already. So 25 divided by 3 is 8.3. I apologize for my cat. 8 times 3 plus, well, what's 8 times 3? I don't know. 24 plus 1. So cool, we get a 1. So we can plug in a 1 here. And we essentially do the same thing. I'm sorry for my cat. So essentially we do the same thing here. We grab it, 1 squared, and let's just skip the formalities of, what I did down here. So 1 squared, Q3 plus R, we know that, 1 divided by 3 is 0, so we have 1, 0, 3. 0 times 3 is 0, so we need a plus 1 to fulfill this. We get a 1. Now, you're going to be saying, okay, this is going to take a lot of time to really draw these out. But if you think just a bit, and I don't mean to insult you by saying that, there's only so many different combinations that we can have. And so eventually you can just skip all this and just go into writing and finding out what your remainder is. And we'll see that pretty soon here. So now we're dealing with a 1, and 1 requires 1 extra step. So let's just start how we always would if we were to land on a 0, and take our remainder down here, 1 squared, Q3 plus R. I mean, as you can tell already, we already know that it's 1 as a remainder, so we didn't even have to do this at all, because we already know 1 is our remainder from the previous problem. So now that we have our remainder, we want to multiply it by our base, which is 5. So that gives us 5, of course. And now that we have our 5, we can write it like any other problem and just solve it. So 5 divided by 3 is 1.6. So just 1, 3, 3 times 1 is 3. So that means we have to have a 2. And that is our remainder. And we only do that next step when we are jumping to a 1. So in this case, we're jumping to another 1. So let's take our, let me erase this so it's not so convoluted. I apologize if it's convoluted. So now we want to jump to another 1. So you do the same thing. we can just expand this out to 4. 4 divided by 3 is 1, and our remainder is 1. 1 times 5 is 5, and from the work that we already did, we know that's 2. So now we are jumping from 2 to 0, and we kind of already did that, right? So you don't even have to work this out. I'm going to, just to show you. That's because I forgot, to be honest. But we get 4 divided by 3, which is 4, 1, 2, 1, 3, plus 1, so that's just 1. And so we've already done all this before. So 1, 1, 2, 2, it's just a pattern, 1, 1, 1. Which means that 1 is our remainder. I'm a little bit slow, so it takes me a little bit to get the pattern, but I'm sure that you, especially with good bookkeeping, you can get pretty far with only having to do 2 or 3 equations. So good for you if you can do that. I am proud of you. Alright. And you could do this for any type. If you need to find a remainder of 4, if you need to find a remainder of 7, it's fairly straightforward, and shouldn't take that much work, or shouldn't be too hard. But let's move on to sort of this last grouping of questions that I wanted to focus on, and that's where you need to verify statements. So you can have like a really easy one or a slightly harder one, where it'll just be, I'm sorry for this, it'll just be normal congruency, where it gives you all the information you need. 45 is congruent to 3 modulus 6. If you were curious, it's written in this form, right? Or something similar to this. This 3 here would actually be your remainder, and your mod would be your mod. And your quotient would be, what you get from that, and your n would be this, 45. But it's essentially the same thing. But how would we verify this? Well, just by what I did. I don't know why I erased it, to be honest. But 45 is our n. We know 3 is our remainder, and we know mod 6 is our modulus. So we're dividing it by 6, which means you get 7.5. So let's start at 7. Our mod is 6, so multiply by 6. And our remainder is 3, because that's our remainder. So how do we verify this? Well, 7 times 6 is 42, plus 3, that's 45. Nice. Let's look at another easy one. Let's look at 104 is congruent to 2 mod 6. As I said before, this can be written as, with some slight adjustments. So we have 104 is congruent to, that's 104 divided by 2. 52 times our mod 2. Oh, I'm sorry. I am so sorry. 104 divided by 6. See, even I mess up, guys. So we have 17 multiplied by our mod plus 2. So what's 17 times 6? 102 plus 2, that's 104. So these are pretty easy. You might encounter something like this. So let's say we're given a statement here where we have 45 squared is congruent to 3 squared modulus 6. Now this question sort of goes into the theory of like what this statement means here. And when I mean this statement, I mean even just like regular statements like this, right? Even without the square. Essentially what this means is that if this was to be A and if this was to be B, it's essentially saying that A and B have to have the same remainder. And I'm too lazy to write that all out. So A and B have to have the same remainder. So when we have questions where, like before, we had to verify, and they're pretty easy, we could just write it out, solve for, qm plus r, get a remainder, and we're done. But with these, it takes a little bit more of thinking, but it's not too difficult. So in fact, we can actually just ignore this square and just write it as this, and then solve it as you would. So we have 45 is congruent to 45 divided by 3, which is 15. I'm sorry, not divided by 3. Divided by 6, you silly goose. 7, 6 plus 3. So let's just check and make sure that's true. So we have 42 plus 3. Okay, that's turns out to be good. But we're not done, obviously. So we have a remainder of 3 here. So our 3 we actually need to square, because of course we are squaring it here. That gives us 9. And then with our 9, we can treat that as our base. And sort of write it as this. 9 is congruent to q m plus r. And then essentially we just plug like we always do. So 9 divided by 6 is 1.5. So 1, 6 plus 3. And as we can see, they both share the same remainder. So since A and B share the same remainder, I'm not going to write this out, they're good. But yeah, essentially you'll take this pathway. It's not really a lot of work. Just square your remainder and solve as you normally would. So I hope this video wasn't too confusing. I hope you guys could understand me clearly and whatnot. I appreciate the time if you watch this video all the way through, and if not, then hopefully this helped you and you're not gonna leave any mad comments below. But yeah, I'll see you guys later. I'll try and upload a video on how to solve for congruences for x, but if not, then this might be the last time you see me. Anyways, thanks for watching and bye.